Gravy make it splash like Pippin. Shit, that's nothing. Splash. Everybody call me Big Pimpin'. No, I ain't.
Gas chromatography. Gas chromatography, which is GC, is a technique that we use to analyze and separate volatile substances. It is involving vaporizing a sample and placing it through a column coated with a stationary paste. Nanoplastic, which is NPS, is an emerging pollutant that are gaining increasingly attention due to their extremely small size, which is less than 1 micrometer, will make them difficulties to detect and study. The study of Okofo and Thomas 2024 employed fluorescence gas chromatography per spectrometry combined with ultrafiltration to detect 9 types of NPS in drinking and environmental water sample, while Zhu et al. 2023 assessed the efficiency of wastewater treatment plant in removing NPS and found that the removal rate was lower compared to the microplastic, while Zhu et al. 2022 reported that PP and PE were the dominant NPS detected in surface and groundwater. All these three studies that demonstrate that GC is highly effective for the identification and quantification of NPS in water sample.
Firstly, the sampling process involved the collection of water samples from multiple environmental sources in Queensland, Australia. These include wastewater treatment plants, influent and influent, surface water such as rivers and reservoirs, stormwater, municipal lab water, and commercial bottled water. All samples were collected following standard microplastic sampling protocols using grab sampling technique. To prevent contamination, pre-cleaned stainless steel bottles were used for collecting influent and effluent wastewater 1 to 2 liters, while 5-liter glass bottles were used for municipal tap water. Bottled water sample 1.2 liter were purchased directly from retail outlets. Before use, all bottles were thoroughly rinsed with acetone, trichloromethane, DCM, and molecule ultra-pure water. After collection, the bottles were tightly sealed using DCM clean aluminium foil and metal lids, minimizing the risk of airborne contamination.
As my part of quality control, fill blanks using milk water we also include during sampling. These blanks help to detect any background contamination during transportation or handling. All water samples we immediately transport to the laboratory and store at -4 degrees Celsius until further analysis. In this study by Su et al. 2023, nanoplastic concentration in wastewater influent reached up to 3.15 microgram per liter, while effluent levels will be significantly reduced, highlighting the need to analyze both untreated and treated water. Meanwhile, Okofo and Thomas 2024 reinforced the effectiveness of this sampling method by successfully detecting nanoplastics such as polyethylene, PE, polypropylene, PP, and PET across multiple water sources.
In a study by Zhu et al. 2022, surface water and groundwater sampling in the Fuhe River, Jiangxi, China, involved collecting 200 liters of water from 6 locations using a stainless steel submersible pump. Samples were stored in 25-liter polyethylene bottle that had been rinsed with ultra-pure water and delivered to the laboratory within a day. Nanoplastic were analyzed using a combination of micro and ultrafiltration, hydrogen peroxide distillation, and pyrolysis GCMS, which successfully detected a variety of plastic polymers such as PMMA, PP, PS, PE, PET, and PA. This technique was shown to be more sensitive than conventional spectroscopic method in detecting particles below 1 micrometer.
In the study by Okofo and Thomas, drinking and environmental water samples were collected from different Australian sources, for example, wastewater, influent and effluent, reservoir water, surface water, tap water and bottled water using certified microplastic technique. Next, stainless steel and glass material were pre-cleaned with acetone and DCM and millip water. Therefore, samples were kept using DCM clean, metal lid and aluminium foil, and then stored at -4 degrees Celsius.
Two different studies, Xu et al. 2023 and Xu et al. 2022, use pyrolysis gas chromatography mass spectrometry to analyze and detect nanoplastic in water. The 2022 study focused on groundwater and surface water and show how effective this method for detect nanoplastic by using specific ion markers for PET. Meanwhile, the 2023 study applied the same method to wastewater treatment plants to see how well the treatment can remove microplastic and nanoplastic. Both studies use the same sample detection, which is hydrogen peroxide digestion and ultrafiltration.
And next, for the analysis technique from journal Okfa and Thomas 2024, use pyrolysis chromatography to detect nanoplastic in water. They identified 9 types of plastic and it was confirmed the size between 100 to 930 nanometer using dynamic light scattering. This method includes strict quality check and it is accurate more than traditional technique.
For the data and the result analysis, Table 1 shows nanoplastic concentration across various water types. The highest level were found in PVC, polyvinyl chloride, which is 0.49 and 3.46 microgram per liter, followed by PE and PET. Polycarbonate PC was below detection limit. This result follow Okofor and Thomas 2024. Highlight that nanoplastic level vary by polymer type and water source, including wastewater, bottled water, and surface water, suggesting that different pollution level and exposure risk.
Next, a study by Xu et al. In 2023, conducted in China, revealed that the mass concentration of microplastic and PEs and nanoplastic and PEs in wastewater treatment plants WWT PEs A and B significantly decreased after undergoing 3 stages of treatment. WWT PEs A and B recorded removal efficiencies of 93.3% and 93.7% respectively. Based on calculation conducted in the study, the estimated annual input of MPs and NPs was 4.801 tons for plant A and 0.824 tons for plant B. The study recommended the implementation of more advanced tertiary treatment technologies to further remove MPs, particularly NPs, from wastewater before going discharged into the environment. Next, we move on to the final study, also by Xu et al. In 2022, conducted in the Fuhe River, China, which found that the mass concentration of nanoplastic and PEs in surface water is high and contaminated, recorded in the range of 0.283 to 0.793 micrograms per liter. Meanwhile, the concentration of NPs in groundwater is lower, ranging from 0.021 to 0.203 micrograms per liter. This is because the effectiveness of natural filtration along the river bank reduced the rate of NPs penetration into groundwater. During the sample treatment process using hydrogen peroxide and filtration, a small portion of the sample may be lost, resulting in lower NPs concentration readings. However, this study has successfully provided a solid foundation for further research. That's all for me.
For table 1, 2, and 3, summarize that nanoplastic concentration from G study, Okofor and Thomas 2024, U et al. 2023, and U et al. 2022. Okofor and Thomas reported low concentration 0.04 until 3.46 microgram per liter across various water sources. U et al. 2023 higher level in wastewater up to 11.28 microgram per liter, but not a strong removal efficiency. U et al. 2022 observed that lower level in groundwater compared to surface water, likely due to natural filtration. All studies commonly identify that polyethylene and polypropylene as dominant polymers, though they differ in sample type, pollution level, and environmental setting. Next.
Conclusion that we can make from this case study is gas chromatography is a useful method for detecting and measuring nanoplastic in a different type of water such as river, water, wastewater, and also groundwater. This study also review PE iaitu polyethylene and PP polypropylene were the most common type of nanoplastic. Gas chromatography also was able to detect even very small particle than other methods like wastewater treatment plant were able to remove more than 90% of nanoplastic, but some were still found in untreated water. Overall, this method is important for helping us understanding and control the nanoplastic pollution in our environment.